So there is an observable given here in 3 by 3 matrix representation, and we need to find its eigenvalue and eigenvectors, and then give some physical example. So I've just rewritten this here. This is how we find eigenvalues. Okay, fine. So how do we write determinant? This one, 0 minus lambda square by 2. Okay. Okay. Yeah. This is this number q plus number by 2 plus number by 2 is equals to 0. X number q minus lambda equals to 0. This gives me y equals to 0 and then 1 and minus 1. Okay. 3 eigenvalues since 0, 1 and minus 1. There is no repetition, hence degeneracy. If eigenvalue was something like this 1 1 1, we would call it threefold degeneracy. But it's not there. Okay. Fine. We need to find the eigenvectors. Okay. How do we find the eigenvectors? We need to look at the vectors which are from this, which is basically x minus x equals to 0, or right as okay, yeah, it's like this. So instead of finding this, we just put, instead of finding a determinant, we just plug back here the value of lambda. So yes. Let's say this x is x1, x2, x3. Zero. So what do we get? Okay. So by square root of x2, this is equals to 0. There is 1 by square root of x1 plus x3 is equals to 0. There is n by square root of 0. So and this you can say that x2 is equals to 0. And there is certain relation between x1 and, okay, let's say square root of x3. So x2 is 0, and I can fix either x1 or x3, and from one of them I can just determine what is the possible value of the other. So for simplicity, let's say x3 is equals to 1. That would give me x2 is equals to minus square root of 2. So for lambda is equals to 0, x is, well, okay, now x3 is 1, so x1 is minus square root of 2. So x1 is minus square root of 2. This is 0, and this x3 is 1. Or if one would like to put it in more general sense, this is x1 0, and this is x3 is minus 1 by root 2 of x1. So there are infinitely many eigenvectors which will satisfy this. So lambda is equals to 1. What will be minus lambda? Okay, minus 1, 2, 0, 2, minus 1, 2. Okay. So again, okay, we have minus y1 plus 1 by square root of 2y2 equals to 0. Okay. So, okay, we can fix either one of them. Let's say this will give me y1 is equals to 1 by square root of 2y2. And this gives me y3 is equals to y2 by square root of 2. Since y2 is what? Square root of 2 y1. Y2 is, yeah, so y3 is written in terms of y1, and y2 is also written in terms of y1. So we can just write y is y1, 2 is square root of 2y1, y3 is also square root of, okay, yeah. Okay, so this will be square root of y1 divided by square root of 2, just y1. So y3 is just y1. Again, all the possible values of y1 one can take, and all the vectors will be eigenvectors for lambda is equals to 1. Okay, so same thing can be done for lambda is equals to -1. Let's say it's a z. It will be z1. One part will be just, this will be negative 2, right? Now, what about the physical relation? Okay, so remember how we write bar upon 2. You observe closely. This is for spin half. We want to write something for, let's say, spin 1. At the basis 1, 0, minus 1. These are just magnetic quantum numbers, 0, -1, 1, something like that. You can say 0, 1, 1, 0, 1, 0, 0.